I mentioned this is so much easier than doing a geometry proof. So we're going to go through the properties of equality first. These are not all listed on that sheet of paper I gave you the other day. Okay, the ones with all the proof reasons. Because I expect that you know most of these from Algebra 1. Okay. So remember your teacher back in Algebra 1 would like to teach you how to balance an equation. Whatever you do to one side, you have to do to the other side, right? Those are your properties of equality. So our first one is addition property of equality. So here's an example, a conditional statement. If x minus 3 equals negative 5, then what allows us to solve this equation? We add 3 to both sides, right? This is our addition property of equality. Right?
Is it right to say negative 5 plus 3 equals x?
Sure, you can do that. Usually the way it's going to look, and I'll show you when we get to the proofs, you don't always have to show your work. So like for this next one, this is subtraction property of equality. If x plus 10 equals 21, then x equals... Is this on the test? Yeah, this stuff is on the quiz. That's why I said, when you see this stuff, it's not really new stuff, right? We just have to justify, right? How did we get x equals 11? We had to subtract what from both sides? 10. Okay, multiplication property of equality. So this would be here. Yeah, how would I isolate the variable here? We have to multiply by 2, so x equals negative 6. Division property of equality. So if 3x equals 21, then x equals 7. Okay, hopefully we all know those. Yeah? Those are the easy ones. Okay, the next 3 are going to be used a lot when we do geometry proofs. But for right now, we need to know how they're used in general. So reflexive property, this is basically when something's equal to itself, like a reflection. Right? So A equals A, XY equals XY, 2 equals 2. Symmetric property. This is if A equals B, then B equals A. Okay, sometimes you get an equation, negative 4 equals x, so I can just switch that around to make that x equals negative 4. Okay, yeah, Aaron.
Are these reasons going to be provided on the test?
So the sheet that I gave you guys last Friday, or on Friday, remember the one that had all the list of the theorems and definitions? Yeah. Okay. I'm going to give you can write whatever you want on that. So for each quiz or test, I'll give you a clean copy of this. And if you have it, you'll see these 3, the reflexive, symmetric, and transitive properties are on this list. I did not put addition property, subtraction property, multiplication property, or division because we really only use those for algebra proofs, so you just kind of have to know those. Yeah.
On the test, we only need to know these ones. We don't need to know the other sheets.
We need to know the ones on here. Is that what you're asking?
Oh, you know all those tests for the quiz tomorrow?
No, not all the ones. You only need to know up to where it says transitive property. Okay, don't worry. We'll get there. Okay, transitive property. This is the one that was used. But well, most of them are from a lot of that stuff is from chapter 1 too. So it just builds. Okay, transitive property has 3 parts. So it says if x equals y and y equals 10, what can we put together from those 2 parts to come up with a third part?
X equals 10.
X equals 10. So when you have 2 things that are equal to the same thing, so notice they're both equal to y, we can make those equal to each other. That's the transitive property. Okay, substitution property of equality. if A equals B, then A may be replaced by B in any equation or expression. Okay, the way that we're going to use substitution today is anytime we like simplify something or multiply. So here's an example. What's 2 times 5? 10. Would you say 10 is equivalent to 2 times 5?
Yeah.
So can I use 10 as a substitute for 2 times 5? Yeah. Okay, last one. We should also know, I also don't have this one on that list, distributive property. Right? This is when we get rid of the parentheses. So 2 times 3x plus 1 is going to give us 6x plus 2. All right. Good. So hopefully most of the new ones would be your reflexive, symmetric, transitive, and maybe substitution. The rest of them should look familiar from Algebra 1. Okay. So these are what we're going to have tomorrow. I'll have a couple of statements, and then you'll see I'll have an algebra proof. So we want to state the property that justifies each statement. All you need to do is ask yourself, how do we get from the hypothesis of this conditional statement to the conclusion? If x over 2 equals 7, then x equals 14.
Are we gonna get a list of all the names of them?
Well, what I was just mentioning. I'm going to give you this, but I'm not going to give you addition, subtraction, multiplication, division, distributive property. Okay? But the other ones are on here. Okay, Aaron?
Would it be multiplication?
It is multiplication.
Could we just say multiplication cross and multiplication?
Yep. Yeah. We could even abbreviate here, like, yeah, you could do like, you could even like MULT, that's fine. I'm totally fine with abbreviating. Okay, next one. If x equals 5 and b equals 5, then x equals b. Yeah, is that what you're going to say? Transitive?
Do we have to write equality?
Don't worry about writing up equality. That's okay. Next one. If xy minus ab equals wz minus ab, then xy equals wz. What do you think? Addition property. Why is this one addition? What did I get rid of both sides? The minus AB. How would I get rid of that? Well, by adding AB. Remember, these are measurements. So we don't know what the measure of AB is, but I can add that to both sides. Measure of angle B equals measure of angle B. This is our reflexive property. Okay, good. All right, so here we have an algebra proof. I've given you all the statements. So we are given 3x plus 5 over 2 is equal to 7. We want to prove that x equals 3.
You would say given.
All right, first step, given. Okay, to go from step 1 to step 2, multiplication property. So, okay. Number 3, did I change the value of anything, or did I just replace it with something equivalent? This is substitution. This is where it gets a little weird.
I thought it would be the
I thought it was gonna be the parentheses one.
Okay, but notice what actually happens here. The 2's cancel. Did I actually distribute here? No. So I'm not doing distributive property. 2 times 7, is that equivalent to 14? Yeah. So I didn't change the value. Basically, anytime you simplify something, we're going to use substitution for the reason. Because simplifying is substituting. Again, it's like we haven't changed. Notice this 7 here became 2 times 7. I changed the actual value of it. But 2 times 7 to 14, I didn't change the value. I just replaced it with something equivalent. Aaron,
Why is it not subtraction?
what would I have subtracted? That's going to be the next one.
Subtract 5.
Okay, you have to ask yourself, how do I get from step 3 to step 4? What did I do? I got rid of the plus 5 and I subtracted. So this is going to be subtraction property. Okay, last one to get from step 4 to step 5 are prove division. Yeah.
Wait, so it's,
What's that?
you don't write the exact one. Oh, so in the step.
It's-
I thought it was all with this.
Okay.
It looks like delayed by
It's
1.
always the next step justifies how we got, like, the next reason justifies how we got there.
Okay, because I was like, shouldn't it be with the one that you do there?
No, because it's like, what you have to do when you write down your reason is justifying how we got from here to here. So that's the reason. Okay. Let's try one that doesn't have the list of steps. Okay, now, we talked about proofs can be done in multiple ways, so can an algebra proof. It depends on what you want to do next. Your proof can look completely different than the person sitting next to you. As long as we end up with z equals 6 at the end with correct algebra, then we're okay. All right, now, what do you think? There's a couple things we could do. We could...
Wait, I don't understand what that.
So we're going to solve this. We're going to create our own proof. So if forget the proof part for a minute, and I just said solve for z, what would you do first?
I would just times 3.
Okay, we could do that.
I did subtract 5.
You could subtract 5. Both of those are correct options. I usually like to get rid of the constant first. So I'm going to subtract 5. Now, I don't have to actually show subtracting 5. I can just jump to that next, right? Get rid of the 5 here, 1 minus 5. If you want to show that step, you can. It's just not necessary. Now, what did we say? What property was used? Subtraction. Just make sure if you do abbreviate for subtraction, don't use 3 letters because you don't want to get mixed up with subtraction and substitution. So make sure you do a 4th letter for that. Okay, now what?
And multiply by 3.
Okay, we can multiply by 3. Okay, so that would be a negative 2z. If I multiplied by 3, that would make that a negative 12. Are we okay with that? So that would be multiplication. And I think we just have one more. Now we can divide by negative 2, so, whoops. Okay, does that kind of make sense? You've solved equations for the last couple of years. Now you just have to, for the proof, you're just justifying it according to what properties used. Yeah.
So why wasn't this like delayed by 1? Like you said for the other one, or it should be by 1. Sorry, that was not good.
No, it's the same. From here to here, that was a division.
Oh yeah, right.
Yeah. Okay, let's try another one. Okay, so 25 equals negative 7 times y minus 3 plus 5y. All right. What do you think? What would you use as the first step? Okay.
Like distribute the negative 7.
Perfect. So I'll leave the 25. So negative 7y plus 21 plus 5y. Okay. I would combine like terms. Now, did I change the value if I put a negative 2y plus 21? I just replaced it, so I'm going to call this substitution property. Now what would you do next? Okay.
I like divide, or sorry, I subtracted 21.
Subtract 21. Okay, so that will give us what on the left side? And I'll make that a 4. And then divide by negative 2. Now, if I'm being really picky, did I prove that y equals negative 2? Or did I prove that negative 2 equals y?
It's the same thing.
Is it the same
Wait,
thing?
is it okay if I split
We're going to
mine?
switch it.
Like,
You
I didn't-
flipped
I
it at the
didn't
same
write
time?
it.
Yeah.
So I'm just going to throw this in. I'll tell you, I'm not going to be super picky about this, but if I wanted to be, I could. I flip it around. That's called symmetric property.
But isn't y not negative 2 equals y equals y equals negative 2?
Right. And again, the reason is symmetric property of equality. If you didn't do that and you stopped here, I'd give you full credit.
What if you
What
did
if
it like
you
already?
flipped it and didn't write symmetric?
That's fine. You mean like you combined these two steps
No,
into
from
one?
4 equals negative 2y to y equals negative 2 and
That's what I meant. Like if you
So
went
what
from
about,
4
like,
to
if you wrote
if you
it-
went from
I
4 to
went from
6,
4 to 6 and just wrote those.
that would be fine.
You know.
All right. Oh, are we good? Last one. So AB. Okay, AB is congruent to AC.
Doesn't this count?
You'll see it's a combination of algebra and geometry.
Are these gonna
I'm
be
not going to
tests?
give you, you might have some on the homework, but you're basically using algebra for this.
Okay.
Okay, so there's the only geometry part to this is going to be the second statement. I'm going to change this to AB equals AC.
Remember next one's substitution.
Yep. So this is the definition of congruent segments.
Could you just go like straight into the substitution?
So we can't. Here's the problem. These, what we did today were all properties of equality. Is there a property of congruence? Well, there is, but there is no substitution property of congruence. That does not exist. So it seems like kind of a silly step that we have to do, but in order to use substitution property of equality, we got to change that to equals. I know, it's a little tedious sometimes, but I do want to see that step. Now we're going to replace what's AB equal to? 3x plus 15. What's AC equal to? We're use substitution. I'm replacing AB with its equivalent one. Yeah.
But it says like yes. Like what do we actually have to write out the definition?
No. We just write definition.
That's what I did.
Oh no,
Okay.
yeah, you don't have to write all that. You just have to write the name of it. Okay, now what will we do next? Want to do a subtraction or something?
Could we,
What do we want to do?
I would be subtracting.
Which one would you subtract?
7 from 15.
7 from 15?
Oh, I thought it was 17.
Did you also do 5x from 3x in the same?
Yeah, you could do that too. Yeah, you could do it if it's this. So I'll do subtraction twice. You could do it in the same step if you, so what do we have? anytime you have multiple steps with the same reasoning, you could actually list them under the same step. Does that make sense? So I didn't really have to make this too complicated. Okay. Next, we are going to divide and you don't need to do this, but I like to just be as precise as possible.